Hi everyone, welcome to another episode of the Tracerco podcast. I'm Rob Hardy. I'm here as ever with my co-host Bill Rivers. How you doing, Bill? You okay?
I'm doing good. How are you doing, Rob?
Yeah, great. So we got something a bit different today. So far, all of our podcasts have looked at how our technology is used in refining. But like many oil and gas services companies, we're also helping to support customers in the energy transition and low carbon markets as well. So we're going to look into that in a bit more detail today, and we have a guest with us. We've got Chris Golightly with us. Chris is an independent geotechnical and engineering consultant with a specialism in foundations for offshore wind turbines. So hi, Chris. Welcome to the podcast. How are you doing?
Hi, Rob. I'm okay. Looking forward to talking about one of my favourite subjects.
Great. So I know your focus at the moment is in the growing offshore wind industry, but like Tracerco, your roots are in oil and gas as well. So do you want to give us a quick history of your academic background and career up to this day?
Yeah, sure. I graduated from Manchester University in the UK 40 years ago, my goodness, civil engineer. And I got an MSc in geology and then eventually a PhD in geotechnical engineering. And I ended up working for companies like Fugro and then BP for a few years and Shell from about 1990 through to about 2010. But in 2005, I became an independent consultant. I left Shell and I've been independent ever since. I got involved in offshore wind in about 2010 on projects in Germany and then a couple in the UK and France. And I've been working on mostly what we call technical due diligence, which is working on behalf of banks and lenders and developers and assessing projects to see where the gaps might be and where the problems might be. And I've also started recently doing quite a bit of expert witness arbitration work in oil and gas and also in offshore wind. So at my age, that's something you learn how to do quite quickly if you've got enough experience. So that's briefly who I am, unless you've got any more questions.
No, that's great. So just thinking about, we're sort of coming at this from a grout density monitoring angle. So Tracerco, we've used our gamma transmission technology in grout density monitoring. We've used it for many years on installations of jackets in oil and gas platforms, most recently on Johan Sverdrup, offshore in the North Sea. So it's a similar technology to what we talked about previously, gamma transmission, and we spoke about scanning towers on refineries. But this is applying it to subsea grouted connections. So could you talk a little bit about the types of grouted connections that were prevalent in offshore platforms and then the considerations when we go to wind turbines and the new sort of technology in offshore wind?
Yeah, well, in oil and gas platforms, we used to have grouted connections which were designed according to the usual API, RP2A type codes. But oil and gas platforms are very heavy, so the grout in the grout connections tends to be always in compression. In offshore wind, we have two types of foundation. We have monopiles, which are basically driven or drilled steel tubes of a diameter which, when I started in offshore wind in 2010, were about 4 meters in diameter. They're now 10 meters in diameter, is the last one I saw. These are pretty big. They have a very big wall thickness, heavy steel. They're up to 2,000 tons now. They go into the seabed something like 40 to 60 meters in some cases. On top of that monopile is a transition piece, which is the connection to the tower, and then the 3-blade turbine, which are getting up to 12 to 15 megawatts. Now, these things are huge. These things sit on the transition piece. When I started in offshore wind, the transition piece was being connected to the monopile using basically ordinary Portland cement grout. And there was a bit of a fiasco because a lot of monopile projects in Europe were doing this without any shear keys. In the old API code, you had the requirement for shear keys on the surface of the transition piece and the outside of the monopile, which allowed extra strength to the connection. in offshore wind, for a whole variety of horrible reasons, they missed that. And it ended up going to some court cases and out of court settlement. So it was all a bit of a mess. They sorted all that out. But to be honest, although there are a lot of monopiles out there with grouted connections that need monitoring and are being monitored, it's dying off. And the industry is starting to use different techniques, such as bolted flanges, conical connections with shear keys, and now a transition piece free or a TP-less connection. So the whole monopile transition piece is all one. And even the big players like Vattenfall and Ørsted and Equinor, which used to be Statoil, are going to start using that. Mm-hmm. The other technique, the other structure type for fixed structures in water depths of up to about 50 meters is jackets. They're really steel truss structures. They're much lighter than the old oil and gas platforms for obvious reasons. They only have a turbine on top. And those are constructed by the truss jacket being lowered into piles which have been previously driven or drilled into the seabed through a pre-placed seabed subsea frame. And those connections between the stabbed-in jacket legs and the seabed piles which have been installed do need to be grouted and will need to be grouted in the future. The loading regime for offshore wind is quite different. Everything's very dynamic because the whole thing is basically oscillating from side to side due to a combination of wind and wave action coming from different directions. So the loading is not heavy, but it's very cyclic and very dynamic. So that puts a fairly complicated set of loads onto the connections for the monopiles and for the jackets. So basically, there was a need going back 8 to 10 years for some sort of condition monitoring of the grout. And that will continue, but it will become more important for jacket structures as the industry moves on. Yes, we're starting to see jacket structures in deeper water, so anything over 45, 50 meters. There could be 3 or 4 legs. In typhoon and seismic areas, jackets will come in at shallower water because in addition to the wind and the wave loading, you've got typhoon loading and you've got seismic loading. What this all means in a country like Taiwan and Japan is you have to start using jackets at much shallower water depth. So, for example, I saw a project in Taiwan recently in about 35 meters water depth, which had some very big piles and a lot of steel and a jacket. And if that had been in Europe, it would have been a monopile. So as you move into countries in the Far East, like Taiwan and Japan and Korea is happening now, and Vietnam is happening, there are going to be more jackets because the southern North Sea, where most offshore wind has happened, is very flat and very sandy. And there's a lot of infrastructure on the coasts. So it's a lot easier. When you go to these other countries, California, for example, or Brazil or Korea, the seabed topography is a lot different. So you're going to get jackets continuing for many years, even if offshore wind starts to float as it goes into floating. So this need to check and monitor grout integrity is real, and it's going to continue.
Sorry, Chris, just a quick question on that. So
yeah.
I think you sort of alluded to this, but what are the implications if grout isn't checked or isn't assured to be of a quality? What are the implications? And I know you mentioned there was a few legal cases, and I don't know how much detail you can go into, but yeah, I just wondered what could potentially go wrong if the grout isn't checked at install properly.
Yeah, there were court cases, and there were a lot of cases. I mean, we're talking about 20 or more in total monopile projects. A lot of them we never heard about. We heard rumors. They were remediated. Things were done. the grout connections were cracking up. There were no shear keys. Something had to be done quickly in many cases. So a lot of money was spent putting in expensive bearings to take the load rather than the grout. So the grout was forgotten about. In many cases, the whole pile was filled with concrete, for example, in one case. And there were cases. Robin Rig is one in the UK. Greater Gabbard is another. Those things are publicly online. The High Court settlements are all publicly available. It all got very nasty, and it ended up costing a lot of money. Battling between the contractor. Was it the contractor's fault? Was it the principal, the developer's fault? And a lot of them, of course, were settled out of court, no doubt. So that's what happened up until, the mid 2015-ish, when things were not, frankly, it was a systemic design error, to be honest. And there were some questions about how the code was written. But the jacket code of design is because of that is well understood. There's a huge amount of research gone on for jacket grout design, but the result is that there still need to be checks. Not on every structure. I mean, a typical jacket development now might be 800 to 1,000 megawatts. It's getting bigger and bigger. You might have anything from 60 to 90, 100 structures. You might have 3 or 4 piles. So you can see that the number of grouted pile connections starts to get up to the 200-300 mark easily. And a certain percentage of those are checked. So 5 to 10% might be checked. And if the due diligence people and the whoever it is, DNV or ABS, whatever, are happy with all of that, then that's what gets done on a regular basis. I could go on and on about that, but it's all part of what we call the operations and maintenance over a typical 25-year design life.
Yeah.
It's one of the things that must be done, and there are companies who do it. Fugro Structural Monitoring do it, and there's a company here in Belgium does it very well, and there are others.
Yeah. And you mentioned sort of ongoing maintenance there. One of our most popular services in Tracerco is flooded member detection on oil platform jacketed structures. So we've seen an interest in that, with there being more wind turbine jacketed structures. But yeah, maybe you could talk a little bit more about ongoing integrity monitoring, or how you see the market developing over the next 10, 20 years on that side of it.
Well, this issue was recognized a few years ago for jackets and of course for monopiles in offshore wind. And there was a project developed by Carbon Trust in the UK it was a competition. And I think at the moment, that one of the ways forward is sonic integrity testing, which I looked into a little bit last year. I don't think that's commercially available yet. But I guess for you guys, the job would be to say, well, we can do this using this, and we think we can do the job cheaper and better. That's what it always boils down to. Because frankly, the offshore wind industry doesn't have the money that the oil industry used to have in the good old days, and they have to bring costs down for offshore. This is all offshore, and they have to, they're still above. The industry is still above the baseline of natural gas, solar, and it has to get down to those levels. So, using the word cost effective is always a great thing to do. And if it can do the job on 10% of new structures on monitoring those grouted connections, great. That's where you're going to have some success.
Yeah, no, that's great. And we've monopolised this a bit with European projects and discussions, Bill, so sorry about that. But the UK's been leading the way in this industry, and we've worked on a lot of projects. We are seeing a lot more monopiles now, but we still do support the installations of the jackets for the substations and that sort of thing. But we should mention the US market and how that's developing and what's going on there as well, just for Bill's benefit, maybe.
Oh, yeah. Well, the German offshore industry's been very active as well, but the UK has been leading in terms of the numbers of gigawatts. You know, the French market is starting as well. All the North Sea countries are developing, but the US is. I've kept an eye on East Coast US developments over the last 5 years, and it's really starting to genuinely happen now. Vineyard Wind in Massachusetts is probably, that's a monopile project that's probably in the lead. A lot of those East Coast projects will be monopiles, or Ørsted, for example, have several projects. BP and Shell have got projects off the East Coast US in partnership with others. BP have got a project in the Irish Sea in the UK with EnBW, the Germans, for example. Mayflower Wind is a Shell project off the coast of the US. So just in the last couple of weeks, there's a lot of gigawatts being talked about for shallow water projects, all the way down from, you know, Massachusetts all the way down to North Carolina and including Maryland. There are maps available online which will show you what the projects are, and they're all going to need to do, you know, grouted connection condition monitoring amongst all kinds of other condition monitoring, accelerometers, you name it, on the nacelle at the top, and the scour protection. You know, the scour protection around the foundation is critical. The cable issues, it's all going to have to come together, and they know what they're doing. I mean, because there's a transition going on. Of course, a lot of European developers and big contractors are in there because, you know, it's a potentially huge market. But it's definitely something which has been slow in taking off for a whole variety of reasons. But I'm sure now it is going to start moving, yeah. And California, who knows? That's going to be floating. So
Yeah.
So, just quick, what about the Gulf? That's like kind of near and dear to my heart, since, you know, I live around the Gulf Coast region. I was wondering, I know as I travel further south in Texas, you're starting to see more and more wind farms popping up, especially on farmland. That's where I normally see it. I see tons and tons of farmers just, you know, giving up sections or acreage of their land in order to produce windmills. Is that starting to become like a big hotbed area besides the East Coast down on the Gulf, or?
well, I only get involved in offshore wind, but I have been involved in Texas, Gulf of Mexico offshore wind projects years ago. The Department of Energy in the US were looking at one off Corpus Christi, which was quite big. So if you look at wind resource maps of the US, okay, California and Oregon, Washington State, and, you know, Maine all the way down, they have the big wind resource. But the wind resource in the Gulf of Mexico it's moderate, but it's there. It just needs to be proved to be economic. The conditions, okay, you need hurricane-proof turbines and structures, but that's been done before. This company called Keystone Engineering in Houston did the first offshore US project called Block Island, which I reviewed, and that's, you know, there's oil and gas expertise in Houston, Galveston, that whole part of the world, you know better than I do. Well, I used to work there a bit years ago, and, you know, the offshore oil and gas business is trying to get into offshore wind very fast, fairly fast. So that's where a lot of the expertise will come from. And the US is building its own installation vessels to get around the Jones Act, the so-called Jones Act, so that they can have it. So the US needs to have its own indigenous. You can't rely on the Danes and the Germans and everybody else forever. You're going to have, you know, Massachusetts, Gulf of Mexico, California, US.
Have to grow up a little bit, essentially.
Well, I'm not going to say that. Yeah, you got to do it yourselves. All the politicians on the East Coast know that. They want that, genuinely. It's good for jobs, it's good for winning elections, I guess.
Okay, that's great, Chris. That's really interesting. Thank you. I don't have any other questions. So I know you've written a lot of articles on this subject. So is there anything you want to flag up to our listeners, or do you want to give out any contact details if they have any questions at all?
Yeah, I spent a lot of time when the problem started in 2010, 2011. I spent quite a few years working on this, and I put 3 or 4 quite big presentations together, which are all available online. So if anybody wants to see those presentations, they can just email me at chris.golightly. That's Golightly. I always have to spell my weird name at hotmail.com, or they could send an email to Bill or Robert, and they'll send something on to me. So academia.edu and ResearchGate, there are presentations on there on this, and tons of other stuff about offshore wind. I'm a sort of open source type of person because I work on my own, and I think, well, yeah, I'll just put it out there and people can use it. So if anybody wants to get in touch and write to me, I can send stuff out, or they can look me up on those sites and you'll find them.
Yeah. Okay. Thanks, Chris.
Yeah.
We really appreciate your time on the podcast, and it was great speaking to you. And we'll get another podcast out soon. But thanks for your time, and goodbye from Bill, Chris, and myself.
Okay. Bye.
Thank you, Chris.
Cheers, guys. Thanks. Bye.
Okay. Cheers.